At this time, I would like to explain section 11.1. Section 11.1 begins on page number 779. There are two major ideas in section 11.1. The first one deals with parallelograms. We'll be looking at the area and the perimeter of a parallelogram, and then also the area of a triangle. First of all, we'll start with a parallelogram. What is a parallelogram? A parallelogram is a four-sided figure in which the opposite sides are parallel. And the symbol for parallel typically is just two lines with two arrows. So we notice here that the top and the bottom are parallel because they have single arrows. The left and the right are parallel. They have double arrows. What's the area of a parallelogram? The area of a parallelogram is the base, the length of the base multiplied by the length of the height. What's critical, however, is that the height has to be perpendicular to the base. All right? So the area of a parallelogram is base times height, and these two dimensions are going to be perpendicular to each other. By the way, this is also true in a triangle. The area of a triangle is half of base times height. Again, the base and the height are perpendicular to one another. The perimeter of the parallelogram is the distance around the parallelogram. And again, here we have the symbol for a parallelogram. All right, and then the area for a triangle is half of base times height. Let's take a look at some problems here. Let's imagine I have a parallelogram in which the top and bottom have a length of 21 from left to right, and that the slant height is 17. If we're going to find area, the area is base times height. Notice we do not have the real dimension here, height, h. But using the Pythagorean theorem, we could say 8 squared plus h squared equals 17 squared. H squared plus 8 squared is 17 squared. If you take 17 squared and subtract 8 squared, you will find that h squared is 15 squared, or h is 15. So the real height is 15. So the area, therefore, is the base of 21 multiplied by the real height of 15, giving us an area of 315. Area of a parallelogram, base times height. This problem had a dimension 8 from here to here, but the real base is actually up here, 21. The total base, that is, 21 times 15 gives me an area of 315. I'd like to look at specifically problem number 3 today and remind you of the 3 lengths in a 30, 60, 90 triangle. Problem number 3, page 783. I notice I have a 60-degree angle there that is labeled in the bottom left corner. I want to remind you that in a 30, 60, 90 triangle, the lengths of the sides are s, that's the side across from the 30, s root of 3, the side across from the 60, and 2s, the side across from the 90. S root of 3, and 2s. So in this problem, number 3, I notice that the slant height, which is 2s, is 20. What I'm going to do then is set 2s equal to 20. Solving that problem, I get s is 10. The side across from the 30 is 10, so that's this length right down here is 10s. So the real height, you should be able to calculate then as that multiplied by the root of 3, or root of 3 times 10. And knowing the real height is root of 3 times 10 and the base is 12, you should be able to find the area and also the perimeter. Again, in a 30, 60, 90 degree triangle, the side across from the 30 is s. The side across from the 60 is s root of 3. The side across from the 90 is twice s. Let's move on to problem number 4. Problem number 4 includes a 45 degree angle. I want to remind you that in a 45 degree angle or triangle, the relationship between the sides is s root of 2. If the side across from the 45 has a length of s, then the hypotenuse would be that times the root of 2. So in problem number 4, I noticed that the dimension across from the 45 is 5. So this is a 5, 5, 5 root of 2. That's your slant height, which becomes then critical for finding perimeter, and the real height of 5 critical for finding area. Area, base times height, perimeter, the top, the bottom, the left, and the right, which were both slants. Problem number 17 is again a 30, 60, 90 triangle. I notice in that problem that I'm given the side across from the hypotenuse is 30 units long. Again, in a 30, 60, 90 triangle, I have 3 sides, s across from the 30, s root of 3, the side across from the 60, and the side across from the 90 is 2s. In this problem, since the side across from the 90 is 2s, then 2s equals 30. You should be able to solve for s, which is going to be this dimension here. And once you know s, you can multiply it by the root of 3, and you will know the height of the parallelogram. Knowing the height of the parallelogram, you will be able to find the area. Area is base times height. Problem 22 is a bit complicated. I want to start out by finding the base of the parallelogram. I've labeled the base of the parallelogram n. So I'm trying to find the length of this unit right here. I notice that I have a 40-degree angle here, and I notice that this side is 18. I'm reminding you with the acronym SOHCAHTOA, the sine is the opposite over the adjacent. So the sine of 40 is the opposite length, 18, divided by the side across from the n, the hypotenuse, n. So n is equal to 18 divided by sine 40, which will give me the base of the parallelogram. By the same token, you can calculate that the angle in this corner is 40 degrees, and then use the cosine function to find h, the height of the parallelogram. The cosine of 40 is the adjacent side h divided by the hypotenuse 22. And once I know h, using that trig function, I will be able to find the area of the parallelogram, which is h times the base that I solve for when I solve for n. Your assignment today is problems on page 783 and 784, problems 1 through 25. Thank you.